Alright guys, welcome to another video on probability. Here we are going to look at the definition of probability, the three approaches to probability definition. We also look at some of the basic terms and probability for which you need to clearly understand what probability is. Now let's zoom into our main. What is probability? I may ask. Probability refers to the chance an event happening or not happening. It is a number lying between 0 and 1. So we have probability lying between 0 and 1. Where 0 means the event will not occur, and 1 means the event will occur. Meaning that if you are getting a probability of 1, meaning that you're 100% sure that the event is going to happen. And note that whenever you are solving probability, always bear in mind that your answer you're going to get shouldn't exceed 1. And it shouldn't be also what less than 0, but it can be 0 or 1 inclusive. Now, let's look at some of the approaches to probability definition. The first one is the classical approach, which is also known as the theoretical approach. What does this approach say about probability? It defines probability based on the assumption that all outcomes are equally likely and exhaustive. Also known as the priori probability. That is, probability is determined before any experiment is performed and is based on logic, reasoning, or symmetry. What this one means is that before you even undertake the experiment to know the outcome and therefore determine the probability, you already have in mind that this is what is going to happen, or this is what the probability is going to be. Let me give you an example. When you're about to conduct an experiment of tossing a coin, then you know that when you toss a coin, you have two possible outcomes, the head or the tail. So you know in advance that by the end the coin lands, you can either have a head or a tail. So you know the probability in advance. Therefore, the probability of obtaining a head is 1/2, and that of a tail is also 1/2. So you know this 1/2 in advance before you perform the experiment. That's how the classical approach defines probability. As the probability is determined before any experiment is performed. Now let's look at the empirical or the frequentist approach. It also defines probability as the long-term relative frequency of an event occurring based on repeated trials. It's also known as the posteriori. It's also known as the posteriori. Why? Because probability is determined after observing outcomes from repeated experiments or historical data. That is, the data is based on relative frequency of events. Okay. Another example is if you have, let's say, 30 days, that's in a month, and you want to find then the number of rains within that month. You can count, right? You can count, let's say, out of the 30 days within that month, we had about 10 days in which we had a rain. So you can say that 10 over 30, and it becomes 1/3. So we observe the outcomes on repeated experiment. And here in our example, the repeated experiment is the number of rains out of the total number of days we have within that particular month. Now let's look at the last one, which is the subjective approach. The subjective approach of probability is based on individual's perception, your belief, your experience or the degree of confidence about how likely an event is to occur. And this type of approach, we normally find it in our day in, day out activities where an economist will come out or a policymaker will come out that, oh, well, it is likely that we are going to experience or inflation is going to grow by this percentage next month. So where is just a probability they are undertaking. It's based on the what? Based on their what experience or what personal belief that probably the inflation, we are going to have inflation increase by certain percentage in the what ensuing month or in the ensuing days. So it's subjective based on what personal belief. And normally we use the subjective approach if we don't have enough information or what data to make that belief or to make that assumption. So when there's no enough information or data, that's why we tend to use a subjective approach. Now let's come to basic terms you need to know in probability. The first one is random experiment. What's random experiment? You can also call it an act or a trial. It is an activity that leads to the occurrence of one and only one of several possible outcomes, which is not likely to be known until its completion. And it is not perfectly what? Predictable. Good. Now you know that when you roll a die, we have these possible outcomes. That's 1, 6. But now you are about to perform an experiment. You don't know which of the numbers would land until you perform the experiment. Until you perform the experiment, you don't know. They are saying that it leads to the occurrence of only one of the what several possible outcomes. You can have 2 and 3 landing at the same time. So when you perform an experiment, either 2 show only, or 1 can show, or 6 will show. You can have 2 of them showing at the same time. Then what is a sample space? A set of all possible distinct outcomes or events for a random experiment. So when you toss a coin, an example is you tossing a coin. So the sample space is what? Head or what? Tail. Roll a die, the sample space is from 1 to 6. These are the what? Sample space. And you can represent the sample space by listing all the what? Possible outcomes. Or you can use a tree diagram. So when I throw or toss a coin, using can do that by listing. My list have head or tail. You can also use a tree diagram to represent the sample space. You can also do like this. So first toss of a coin, we have head or a tail. I can also represent that one with a Venn diagram and have a head or a tail. Whatever way you want to represent your sample space. And let's go to one major thing, which is mutually exclusive events or disjoint event. Mutually exclusive event or disjoint event. What are they? If 2 or more events cannot occur simultaneously in a single trial of an experiment, then we are saying that they are mutually exclusive. In other words, 2 events are mutually exclusive if the occurrence of one of them prevents or rules out the occurrence of the other. An example is you tossing a coin. If the head shows, the tail cannot what shows. Or if the tail shows, the head cannot show. Therefore, we can say that the head and the tail can't happen at the same time or they can't show at the same time. For example, numbers 2 and 3 cannot occur simultaneously on the roll of a dice. And it's true. When you roll a die, you can have 2 and 3 showing at the same time. One of them will show definitely. And if we are saying that events are what mutually what exclusive, Then mathematically you can say that, let's say event A, intersection what event B can't occur, then mean that the probability of what A intersection B is what is 0. And in a Venn diagram form, you can say that they are disjoint. We have event A and what event B. They don't have anything common between them that connects the event. So A intersection B is 0 in mutually exclusive event. Then for collectively exhaustive event or mutually exhaustive event, we are saying that their events or event are said to be mutually exhaustive if at least one of them must necessarily occur. For example, in the case of tossing a coin, you have two events, right? You have the head and the tail, and they are said to be what mutually exhaustive, as one of the events must necessarily occur. Thus, it contains the possible outcomes from the experiment. That's a mutually exhaustive. Anytime you do it, at least one of them will happen. At least one of them will occur. Then we have independent and dependent event. Independent and dependent event. When do we say an event is independent? You're saying that two events are set to independent if information about one tells nothing about the occurrence of other. In other words, outcome of one event does not affect and is not affected by the other event. However, when two or more events are dependent, then one event tells something about the other. In other words, one event is affected by the what? By the other. Also, for independent event, we are saying that two events are said to be independent. Let's say we have event A and B. So we have event A and this event A and B are said to be independent if probability of A and B, which is A intersection B, is equal to the product of their what? Individual probability. Then we are saying that such events are said to be independent. Independent. For dependent probability, we are going to cover it in our next video on what's also known as conditional probability. We are going to cover them in our next video. Equal likely event. Events are said to be equally likely when there is equal chance of occurring. That is, one event does not occur more often than the other. An example is if an unbiased coin or dice is thrown, each phase may be expected to occur in equal numbers in the long run. However, if a coin or a dice is biased, then each phase is not expected to appear equally. What this one means is that if you are being unbiased, then when you roll a die or toss a coin, in the long run, you expect that you are going to have what? Equal number of what? Head or tails. Other than that, if you are biased in your experiment, then you would see that you can either have more head or more tail, which differ the equally likely event. Then complementary event. Complementary event. Let's say we have event E and the other event not E. So not E complement what? Event what? E. So if you are not alive, you are what? Dead. If you are not asleep, you are awake, going about your daily activities. Complement of an event E is, so a complement, you can write it as this, others write it as this, or you write it with a small c, denoting that this event is a complement of the event E. For example, when a coin is tossed, getting a head and tail are complementary event of each other, because if you don't get a head, you are getting a tail, or if it is not a tail, then it is a head. Also bear in mind that if you have an event A, then we add its complement, that is not A, give us 1. So bear in mind, let's take note of this. If you have event A and you want to find not A, the summation of event A and not A should give us 1. What is a sample point? A sample point represents one possible outcome among all possible outcomes in an experiment. They are the building blocks of sample space. Good. Now, when you toss point, you have heard so just the head, getting a head is a what? Is a sample point, or getting a tail is a what? Also a sample point. In the same vein, if you have a die, you have 1, 2, 3, 4, 5, and 6. If you roll a die and you get a 3, but the sample point out of the what? Among the possible outcomes have. And let's look at some of the glossary of terms using probability. So we are going to focus on two events, A and B. So if you have A union B, A, which means that what? It represents the occurrence of what? Either what? A or A or B. And under this, you have to be careful. The question states that these two events are mutually what? Exclusive or not mutually exclusive. You need to be careful. Now let's examine them one after the other. So if A and B, event A and B are mutually exclusive, then you can say that probability of A union B is given by probability of A plus probability of, since these two events are what? Mutually exclusive, meaning that they are probability of A intersection B is 0. Also, if they are not, that is not mutually exclusive, then you can say the probability of A union equal to probability of A plus probability of minus probability of A intersection. Then as I've already indicated, if you have probability of A intersection B is given by, and probability of A times probability for independent event. Thank you. Let's watch out for the next video on probability.